In this final video in our three-part lighting series, we're going to go over baked lighting. We're going to go over what exactly is baked lighting and how do we set it up inside of Unreal Engine 5. We're going to go over exactly how it works, as it requires not just us messing around with settings inside of Unreal Engine, but also how we set up our lights and our geometry for our levels. We're going to go over what Lightmass is, as well as what is the difference between the CPU and GPU Lightmass. We're going to go over what are light maps and how we have to really think about the light maps and the UVs that we actually use on geometry as we want to use for a baked lighting workflow. We're also going to go over what is light mobility and how we can actually set that up properly and make sure that things are optimized and efficient. And then we'll go over some final pros and cons for the baked lighting workflow and talk about why we would use baked lighting over a method like Lumen. So with that being said, let's get started. This final video, we're going to go over baked lighting itself. We've gone over general understandings of what lighting is for games. The second video, we went over what Lumen is. Now let's go over baked lighting. Now, this actual system was something that was very widely used in the previous generations, especially when using Unreal Engine 4 as our primary one. But I do want to make note, baked lighting is not an Unreal Engine specific thing. It is a general workflow that's been used in proprietary as well as other user open-faced engines like Unity, CryEngine, as well as a few others. I myself, when I was working on some of the Call of Duty studios, we were always working on levels with baked lighting, and it was a pain because we would actually never have a real-time visualization of what our scenes looked like. We'd actually have to wait till everything's rendered before we actually got to see what we were looking at, which was always a pain. Though this is not the case for Unreal Engine. So what exactly is baked lighting? Baked lighting is a technique, in this case inside of Unreal Engine, that will pre-calculate lighting before the game is actually played. What we're going to do is that you will see that the engine itself uses a system called the Lightmass to store the results of all these calculations onto light maps that are saved onto the geometry itself. Everything is calculated. Shadows, indirect lighting, light bounces, everything's calculated for every frame. Because this calculation is done ahead of time and during this light build, the games themselves are going to run fairly smoothly. Unreal Engine will display everything pre-computed, it will bake everything efficiently, and it will produce very high quality shadows as well as globe illumination as well. Now, the trade-off is that the scene itself has to be very fixed and static. There cannot be any large dynamic movements or changes within the scenes. They're also really tough to do for exterior scenes, but are really well done for interior scenes. Lumen itself actually shines a lot better for exterior scenes that are being lit dynamically. That will definitely kind of show the difference between the two itself. So why will we use baked lighting? One, baked lighting is a standard that's been done for many years. It's something that's been around, since we actually could start to calculate lights themselves inside of games outside of using, I think we were using at one point very early on, vertex paint to try and apply fake shadows and fake highlights and stuff. But when we actually started having light assets that could actually calculate shadows, we really had to look into how to bake the lighting down ahead of time, because you cannot always have everything be dynamically rendered. That's just not possible. Baked lighting itself, is, for the most part used nowadays for mobile devices, short end platforms like Switch 2 that are, not as powerful as high end ones like the PlayStation or Xbox, as well as PC. They're also really good for VR experiences because VR has their own different constraints. They have to have, in some cases, 75 to 90 FPS and have to render technically two smaller little monitors for each eye. So there's a different type of performance kind of hit for VR itself. So that's why you want to use something like baked lighting versus Lumen, because it's really hard to get down with. One other thing is that, Lumen, of course, is not as stable. There'll be a lot of noise, flickering, temporal artifacting, whereas with baked lighting, that's not really the case. You will see everything pre-calculated ahead of time, so you're not going to see these kind of dynamic changes happening every time you move your head. That's kind of one of the other things. Though I will say that there are some AAA games that are using baked lighting. A funny example is actually here, Joachim Stixon, the artist that has this golden gasoline station. This was rendered in Unreal Engine 4, but it's using baked lighting to showcase the kind of dusk to dawn type of look to your scenes. Joachim Stixon is the world art director for Embark Studios that worked on Arc Raiders, and Arc Raiders actually uses baked lighting. They use something called light scenarios, which is something that we probably will actually talk more about in a different video because it's a part of a much larger system for sub-levels. But what they do is they'll pre-calculate different types of levels that will have the light done. And what I mean by levels is it's not like they just copy the one level and just make it daytime, the other one nighttime. You can take only the lighting components of the scene, not affect the actual geometry itself, but you can just take essentially a layer of just the lights themselves, and you can swap them out after they're pre-baked. And you can have it as a scenario using a blueprint that on load, you can choose to have daytime, nighttime, overcast, dusk, dawn, or like golden hour, blue hour, however type of light scenario you want, you can totally get down with it. And it's just a very simple switch in real time, or in their case, probably when they're applying the players to a lobby for Arc Raiders, it will choose the map and also choose what time of day for that map. It won't be dynamic necessarily, but it will still provide pretty solid performance as you're trying to run like through that type of a game. So how does baked lighting work essentially? Well, what will happen is inside of Unreal Engine, when you have your level set up, you're going to have there's a little simple area in the viewport that will allow you to start to bake. And what will happen is you can choose the quality level. There's, of course, like low, medium, high production quality, and there will be a Lightmass setting. The Lightmass will actually tell you to choose, what types of different settings for things. How strong do you want the global illumination? How much detail level size do you want? How smooth you want the lighting to be? Because sometimes, if you can see, there's what the default settings look like, what they look like when they're being tested, and then over time when they're actually refined, you can actually get your scene to render fairly clean. But it takes a lot of processing, and what will happen is when you hit build, a object known as the swarm agent, which is essentially the rendering agent, will go through and start to take time to calculate what's in the scene, what lights are in the scene, and what types of light maps you have for your scene, and slowly start to process this. It's very similar to offline renders, where offline renders take time to render singular frames of either level or frames for an animation. This is one of those things that you have to understand that this workflow will have a bit of a back end of I have to get all this stuff prepared first before I can really see the final product. Just note, depending on how large the scene is and how complex it is, it could take time. My favorite example I always like to show when it comes to things like this is, even though this is an offline render, this is a scene from Coco where this scene alone has 7 million light assets in it and took days, if not weeks, to render a single frame of this animation. Though when you hear that, you're like, how did they get this thing out? Because if it's almost 2 hour long animation at 30 frames, 24 frames technically per second, how did that work? How do we get it in at a reasonable time? Well, we actually have a way to render frames using more than just one PC. There's what we call render farms or swarm agent farms, where you can have PCs that are not being in use with Unreal Engine, like say at night when everyone's gone from work. You can cast off a light build and have all the PCs that are connected on the network to be used simultaneously so that you can actually render this a little bit faster. Because with CPUs in mind, they're a little bit slow because they have to render everything kind of directly in front of it. They cannot parallel render. And that kind of goes into my step of what is the Lightmass itself. Well, again, it's the system that is actually baking the lighting itself. It gathers what's inside of the scene, the light maps, the light map UVs, the geometry itself, how thick, how wide, what types of mobility are for the lights and for the assets themselves, and starts to calculate it. Again, because this is CPU based, it can take a long time to have to render. So you have to, one, be patient, but also understand that what you see when you're working on this before it's being baked may not be the actual final thing. So you have to understand that when you're doing this, you have to really take the time and understand that, like, whatever is being used in the scene, however like the lights are being made or how powerful your PC is, will take time into have to calculating something like this. Again, we have those swarm agents to help with that. But, nowadays, because some studios tend to not use this type of a workflow and use something like Lumen, this is not the case nowadays. But they, not recent in this year, but like recent in Unreal Engine 4, were able to create the GPU Lightmass, which what the GPU Lightmass does is almost somewhat real-time-ish, allows you to actually calculate your lights like this. And you can actually see the scene itself being calculated. Because the GPU is different from the CPU where it can actually do parallel processing, it helps render the scene a little bit faster than you would with the CPU. The problem and downside is that it's not going to be as accurate because it's taking less time to try and calculate. It's not going to be as refined as it would be. So you can see here, this small scene that's being rendered, you can see that it's taking about almost 10 minutes to render, but then when you look at the GPU Lightmass trying to calculate it, it's about half that. But you can see here, I'm seeing some subtle lights casting shadows here, whereas like I only see a smaller version of it, and the materials themselves are appearing a lot brighter than they actually should. You can even see that I have this like light bleed that's happening here, where there's like maybe a light right here, and it's just rendering super bright hotspots. Whereas like when you see this, that's calculated a little bit better, you're not seeing these hotspots actually being rendered. So again, if you need to kind of proof your work a little bit, you can use the GPU Lightmass to kind of quickly render it, but know that it's not going to be as accurate as the CPU Lightmass will end up being. Now, with all of this, we've talked about how the Lightmass is kind of working, where it's starting to calculate your scene. How does global illumination work on this? We've talked about this, how it works in Lumen. How does it work in a baked lighting workflow? Well, thankfully, the Lightmass will calculate global illumination calculations. You have to, of course, adjust your settings here and there to get it to be properly rendered, because sometimes you can actually have it render with, very minimal amounts of bake or amounts of like color bleeding in, but you can still have it so that it actually can, use global illumination in the calculation. A lot of this data on static assets gets saved into the light maps themselves. Though for dynamic global illumination, like say for players, like your characters that are running around, baked light maps that are calculated and static onto a surface is not going to be helpful. But that's where we actually have a secondary thing in our calculations for volumetric light maps, and those will actually allow you to calculate global illumination in kind of these small quadrants, so that as your player starts to move through, it will start to apply the global illumination influence onto that object, and then slowly move around and see it change over time. These all have to be calculated every single time you do a bake, but you can still actually gain global illumination without having to lose any sort of quality from baked lighting workflow. So now, what are light maps themselves? Well, a light map essentially it's a secondary type of texture. One, it's not an accessible texture. It's something that's built into the back end of the engine itself, so you cannot use this for something inside of your materials. But what it does is it will start to calculate your shadows and highlights of your light, your light scenario in Lightmass scene itself, and calculate it so that it can be kind of overlaid on top of the materials, the meshes themselves in the scene. The shadows are going to be static, especially if they're built with a static lighting in mind. But light maps are also very complex in that, one, they have to be used as a secondary UV set, which is something that we've talked about in a previous video on UVing. But Unreal Engine, what it does is on import of an asset, you typically will get a secondary UV set because of light maps themselves. Now, light maps, there's no specific type of texel density of sorts for this. There is, guidelines that you will get from Unreal Engine itself, but a great way to see if your light maps are the proper size is there's actually a optimization viewport that you can actually look at, which is what you see right here. And it'll tell you if your light map value, which by default usually about 32 to 64, if it's too small, it will be rendering blue. But if it's perfect, the Goldilocks, it will be this perfect lime green right here. But if it's red, that's not good. That means that it's too big, and you can probably do with having it be smaller. So something like that will definitely make things a lot easier. So take your time and slowly look at your scenes and make sure that this is all green and not just all red or all blue, because that's not good. If you see this kind of brown tan color, what that means is that this is a dynamic asset, as in a skeletal mesh that has animation to it. And those typically do not calculate light maps because they're typically calculated as movable objects. So there's not going to be any baked lighting on them because they're dynamic. This little thing right here is what we were just talking about in the global illumination frame. These are the visualizations of probes for volumetric light maps. What these little balls are is they calculate where the lights are in the scene, the shadows of the scene, and as your character moves closer to one of these little probes, it will influence and take on that calculated light map data, aka that calculated global illumination on your object, thus allowing you to actually move around and actually see the global illumination change on there. This is separate from the cast shadows, which are usually saved on here unless they're dynamically rendered. So note that these are both different things, but they're used conjunctively because one is helpful for global illumination and one is really helpful for cast shadows, and cast shadows that are statically baked onto a mesh surface. So now let's go over the kind of other big aspect of this, and that is light mobility. We've talked in the first lighting video about settings like this. What this is this tells us what type of shadows and what type of performance this light will kind of give us. You have three options: static, stationary, and movable. Static, for the most part, is, as its name says, it's static. It is the most performant lighting setting that you have, because what happens is that this calculates shadows very statically. Essentially, the shadows themselves do not move. You will set this up so that when it starts to calculate all the props or the kind of architecture of your scene, they just render the shadows there, and that's it. The movable mobility is the opposite of that. This is for dynamic objects. Every light that uses mobility or has the movable mobility will be rendering a dynamic shadow. There's no baked shadow happening at all. This is the most unoptimized and performance heavy type of lighting setting. So you want to make sure you only use this for like one, if not to just whatever's necessary. Like if you have a character moving around, you want their shadows to be cast, make sure that whatever lights that are actually illuminating the scene are set to this movable option so that you can get the dynamic shadows be cast from the player or from the enemy or from whatever dynamic object that's happening inside of the scene. This mobility is also on objects themselves, props, assets. You just have to choose which one it is, because most architecture and most props typically are going to be static. The ones that are going to be movable, interactable, and dynamic will be set to the movable option, so you can actually get dynamic shadows happening from them. Now, there is a nice little caveat, which is the last option, stationary. Stationary is another one of those Goldilocks types of options where what it is it will calculate static shadows and dynamic movable shadows, but it will just make sure that when it's calculating the light itself, that it will choose based off of the mesh's settings themselves too. So if the light's in the area of influence of a static mesh that has static mobility, it will bake static shadows. But if there is a skeletal mesh like the player, it will render dynamic shadows for that player. So that way you don't have to worry about, choosing one or the other, or having two lights where one is the static light and one is the dynamic light. Now, one little kind of limit of stationary is what you'll see right here. And you might have seen this before if you've played around with lights in your scene. This X actually means that this light is a stationary light, but it has hit its performance limit. And what I mean is stationary lights have a small limitation in that you can only have 4 of them be overlapping. And what I mean is every light has that light attenuation kind of range or radius, that area of influence. If 4 of them are interacting with each other and intersecting with that range in mind, then it will, on the 5th one, say you make another stationary light and you put it in there and it's in the same area of influence of the other 4, it will make this little kind of X on the icon and mean that what's going to happen is this object is not rendering dynamic anymore. It will only, even if it's a stationary light, it will only render static shadows. It will only do bake shadows. It will not do anything else dynamic. Now, what I mean all this is you can have as many stationary lights in your scene if you want. Again, I don't mean to have a ton, but note that only 4 of them can be overlapping at a single time in your level. So if they're spaced properly and have like the proper attenuation radius where they're not overlapping, then you're good. But just note, if they overlap too much, then you'll get this issue. Now, all of this in mind, what are the pros and cons for a baked lighting workflow? And it's actually very small, thankfully. But of course, baked lighting, the biggest one is, it is the lowest runtime cost versus, say, Lumen, because you are pre-calculating your lighting and it's very, very good. Now, one con of it kind of connects to it. Long build times. You have to pre-calculate all the lighting in your scene, and that takes hours sometimes to do. Especially with large levels, you have to calculate this stuff ahead of time and can waste time in a development day of an artist. So sometimes you have to either do night builds where you don't see what the lighting actually looks like for your scene and have to wait till the next morning in order to see it. Another pro for this is, of course, great image quality. You will not have ghosting, noise, artifacting, things like you would typically see with Lumen, because it's not trying to temporally blend and dynamically set this stuff up together. But one problem is that it requires a lot of UV management. You have to, sometimes you can let Unreal Engine create those secondary UV sets for your light maps themselves. Or sometimes, depending on how it is, because Unreal Engine doing it automatically may not be the best, you have to manage them yourselves. When we were working on Asgard's Wrath 2, because we were first developing on the Quest 2 headset, which is a very limited piece of hardware, think very just a little steps above a PS2 in some ways. We had to be very strict on our light maps, and we had to be very small with them. Like, our textile density was like 256 per meter. Like, it was very, very tough. We didn't have full PBR materials on there. It was a very, tight performance window that we had to deal with. So you have to do a lot of UV management for a baked workflow. But at least that gives you stable lighting. Stable lighting, but static environmental lighting, which I should put an asterisk on that. You can have dynamic scenes, but it's not going to be as dynamic as light automatically changing as you move objects inside of with Lumen. Like, you can still have some dynamic aspects to it, but it's still going to be stationary. Like, if you want to have like moving emissive materials that are from like LED screens or from like a TV or something, that's not going to bake as well. You can't really do that dynamic. You can't really do that baked. You can only do that dynamically. So there is some static elements that are going to be, this is going to be a lot more of a static type of scene to deal with. It has great GI, but again, less flexible, because again, you have to manage and set up things ahead of time. That's going to be one of the big problems. This is great for VR and low-end hardware, which again, like I mentioned, if you are working in an indie environment and you are running to like a mobile type of scene or VR, or again, like Switch or Switch 2, this is great for you. Only until I think just recently, because like 5.8 just came out, that you will see some bits of Lumen start to come in, but again, there's still, Lumen is a performance monster sometimes, so you have to understand how to manage the expectations for that. Now, one other big con is larger light maps memory usage. So these light maps do have to be calculated and have to be rendered on memory. And depending on how large and how many, that will take up some cost. You lose the cost of calculating the light itself, but you also have to incur the CPU cost of having to pull the light maps themselves and the GPU for having to do draw calls to render that onto the object. There's also the aspect of disk size, because you have to keep all these light maps somewhere on the scene. They are packed like almost like an atlas sheet, but you still have to have them somewhere, and they will kind of run up disk space a little bit. So that's like another little limitation you have to understand when it comes to this type of workflow. Now, why should we use something like this? Ideally, you want to use your baked lighting because you are using maybe interior scenes. Like why would you use this versus like Lumen? One, again, the hardware itself. Depending on what type of hardware you're using, you have to make a choice. And if you're using on the lower end of things, then baked lighting might be your go-to. If your team is very kind of great when it comes to an asset pipeline, you can very easily set up baked lighting a lot easier. You have to manage it through the DCC like asset pipeline, so that you know that you're setting up your Lightmap UVs already, or on the integration aspect when you're getting it into Unreal Engine, that you know to set up your assets ahead of time so that the Lightmap UVs are set up properly. Again, it all comes down to, do you want to manage your lighting expectations and visualize them a lot easier? If you're willing to wait just a bit more, then you can just as easily like gain really great lighting, maybe not as dynamic as Lumen is, but you still will get some pretty good shadows, global illumination calculations. One of the only big issues I will have is emissives are not as strong with a baked lighting workflow versus Lumen. The fact that I can actually create dynamic moving emissive materials and actually in real time see them affect as a lighting source, that's one of the things I do like about Lumen. But you can still have emissives affect the world, though not as dynamic as they should. Like if you want a simple like emissive materials start to kind of cast light and have that color and light injected into the global illumination of your scene, you can do that. But you will not see it dynamically move. That's going to be the thing. So it really kind of depends on just when you first start looking at your scene, when you first start looking at the kind of production for the game that you're trying to work on, understand if you use baked lighting and you're trying to keep things under performance fairly well, you can just as easily apply other rendering techniques and other rendering kind of features or other types of gameplay stuff on top of that. Games like Arc Raiders can have, I believe, like 40 to 60 people. Again, I've never played it, but you can have a certain amount of people in a lobby. You can fight every single one of them. You can scavenge for resources. There's also PvE elements, but you will be able to have all this stuff and still run fairly performant on multiple different types of hardware because you're using a baked workflow versus a Lumen dynamic type of workflow. So this is just the choice that you have to make, that there will be a little bit more of an optimization overhead and you have to take your time to set up these assets, but it can help you in the long run with saving in real-time performance. So that, for the most part, is the kind of understanding of what baked lighting is. Let's actually go over it in a demo inside of Unreal Engine 5 itself. So now that we're inside of Unreal Engine, let's go over what we need to do to even get to baked lighting. And first off, the one thing I'll definitely make sure is when you work on a scene, you want to start with an empty scene. Just like I had mentioned in the first video, always try and start from scratch. File, new, basic, or even empty level. Never try and do the open world ones or try and reuse some of the third person, or like the default levels that you get from like the different templates, because sometimes there might be settings that do not allow you to actually use baked lighting by default. So first off, let's go to project settings because that's where most of the work is going to be. So if we go to rendering, and first off, you want to make sure that you have your dynamic global illumination and your reflection methods both set to none. You can set them to anything else besides Lumen. Lumen will turn on all the other stuff and turn off baked lighting essentially. So you don't want to have any of those. The other option is you need to also make sure that you enable, where is it at? Right here. Allow static lighting. This is the key one. This one will actually make sure that you can actually bake static lights and actually have light maps and shadow maps also generated. Once you have that, then the only other option you need to make sure that you have is inside of here. There's your, of course, your detail settings, which are the settings for the prop itself. But then there's these world settings. These are for the actual level itself. And for the level, you want to make sure you have this force no computed lighting unchecked. If you have this checked, then it will not compute lighting. You never want to have that. So once you have that all taken care of, you're good to start doing your baking. Now, to even start a bake, you want to go up to the build settings. There's a couple different types of builds that you can do, like geometry, landscapes, texture streaming, reflections, if you want to even do some reflection capturing. But the big one is lighting. You can just do lighting only, and that makes it a lot easier. You can choose what type of quality, depending on which one you use, the more it's going to be more longer to take, but it will calculate more accurately. After that, it comes down to if you want to just use your CPU type of light mask or the GPU light mask, which will pop this guy up. Both of them will work either way. This one will actually be a real-time one. So if I hit build right now, it will try to calculate everything based off of your samples and information. Or if you do CPU, it will be taking a lot of this information in right here. This is the Lightmass settings. So right here is using these types of settings. There's an intermix of like the reason why things look so nice and smooth is that there is either high light maps or there's a large number for your packed light maps, or the last one would be the settings that you use for your light mass itself. Anytime you mess with any one of these guys, so indirect lighting smoothness, quality, the amount of bounce lights, and of course this one especially, will make your baking take so much longer. So be very careful as you try to mess around with these settings. But first, let's go over the other aspect, which is, of course, your scene. Because right now, if I hit play and I walk around, as you can see, there's no shadows generating from here. But you can see that as my character walks through the scene, he starts to change colors. And that is actually using the volumetric light maps that I was talking about. This is pre-caching the kind of GI global illumination that would be a part of the scene. And it injects it onto the scene itself so that you can get the proper shadows, but also the proper colors that goes with it. So to take a look and visualize that, by the way, is if you go to the little eyeball right here that turns on, viewport flags, if you go down to visualize, you'll be able to visualize the volumetric light maps. So these little spheres, which there's not just these ones, but there's a ton out here too. These all generate the colors for the probe. So you can understand where the color is going to be coming from and how it injects to any sort of mobile or dynamic asset throughout your scene. These little probes, as you get closer to one, it will start to take on the color information of this one, or it'll move to this one, or any of these other ones. So as your character moves across the scene, it will start to take on the color information that is a part of that one singular probe. So let's uncheck that. Now let's get to the asset portion of this, because for a lot of you, you may not have realized that geometry takes a big amount when it comes to light map or like your baked lighting. So if we open up this actually is a kind of modular wall piece that I made. I didn't just like use small, simple little pieces. As long as you don't have nanite enabled, you usually should have light maps already set up. So Here is what my light maps look like. These actually were made inside of the program that I was using, Maya. But if you have Blender, 3ds Max, or whatever DCC modeling program you use, you can generate a secondary UV set for that. Use that to make sure you turn off the Lightmap Generate UVs option. Because if you have this, it will reset and actually change the Lightmap UVs to something else like that. And as you can see here, it completely removed everything around and changed it up a little bit. But you can still see I still have 2 UV channels. But if, say, you might have multiple UV sets, again, going back to our lesson on UV sets and UVs, you can have many different UV sets for different things. The example I showed in the video before was about, my first UV set was for baked assets, like a baked normal map or a baked ambient occlusion map for like Substance Painter or any other program that will, bake stuff. Then my second UV set was for texel density, orientation of the surfaces for things like wood and stuff. But basically, you're good to choose for how many UV sets you want. So like here, if I want to, I can change where these guys are generated from the index. Again, the index is another term for the UV set. So UV sets, again, are numbered 0 first, then 1, then 2. So right now, my second UV set, which is technically the 1 index, if I move it to 2 and hit apply changes, now I'll have my original UVs and I'll have these generated ones as well. Whichever destination I choose will be the actual index. The other one is your source light map index. What this does is it looks for how things are unwrapped, like say how my UVs look from here, and it will use this as the reference to essentially take what was unwrapped here, all the UV islands, and move them around in a way so that they can be useful for your Lightmap UVs. They're not going to unwrap it in any other weird way. You just have to make sure that you choose which index you want from this. And then the other option is, of course, right here, the Lightmap resolution. Just like I had mentioned before, your Lightmap UV resolution is going to be key because that's the higher the resolution, of course, the more higher detail your scenes look, the more like nice and smooth your surfaces look. But the problem is you will run into an issue where the more higher it is, the more expensive the amount of light maps you're going to have in your scene, which can be a problem. But as we can see here, if you want to actually view this stuff and see if you have the correct types of light maps, if you go to Lit and go to your optimization view modes, there is your light map density. And as you can see, pink is actually what you are selecting. Red is not a good one. You don't want red, you want green typically. Blue means that your light maps are way too low. This perfect lime green, perfect, but red, too much. So it looks like my light map resolution for these guys is a little bit much. But even here, like this cube, you can see that he's blue and you see how big the square is versus like how small these guys are. Let's take a look at this guy, because this, there's two different kinds of ways to actually adjust light map size or light map density size. One is through here inside of the static mesh editor, but you can also override the static mesh editor's value inside of here in the details. This is not permanent like this one. Like if I go to this particular cube 116 and I grab him and I type 256, we're almost there. So 116, let's do it again. Let's do 400. Getting there. Let's try 450. There we go. That's the perfect color. But if I find another cube, like say this one, you can see he's been overwritten to 1000. And it's this one all the way over here, but he's so large. That's the reason why he looks good at green, even though he's 1024 pixels. But if I go to say these guys, these guys are really small. So if I go and actually start to select each and every one of these guys, I might be able to adjust them a little bit because technically speaking, they're the wrong size. So right now they're 500. So what if I do 256? Let's see. No. Let's do 128. Again, I'll say this. Powers of 2 is not necessary, but I just, as my brain always thinks in powers of 2, I like to just do that as a test. So even with 128, that's still too much. So let's do 64. Perfect. But because of this object being scaled independently and not the actual like UV map size, the face is good, but the sides are too much still. So if we reselect these guys and just scale them just like that, so that they're all like kind of equidistant again, we should be able to just have them like this, and then they'll just be perfectly green no matter what. But as I keep making sure that I have the proper greens, we're almost there. So let's take one of these guys and let's override his value. So the one thing I still have an issue with is I don't know why when I'm overriding these static meshes, they go down to 4 when I have them unchecked, which is just really weird. And I'm not sure why, because there's no option to say why they wouldn't be, because these guys by default should be at a 512 resolution. That's the case for it. But for whatever reason, it's 4. But if I do, say, 256, seems like 256 is like the proper number. Now, you also can see here that when I look at this now, this color looks a lot more green than this one. This is kind of one of those, as long as it's green enough or greenish, you're fine. You know, there's no perfect number or perfect value that it will tell you like this is the exact one. As long as everything's within shades of green, you're good. So watch as we go back here. Let me grab the rest of these corridor blocks. We'll do 256 as the option. See, green all the way. That's exactly what we want. So now that we have this, let's take a look at what the scene would look like with a bake. So let's go back into our world settings. And like I said, these guys take so long to do. Let's start to just reset these guys back and let's see how long it would take without them. So let me turn off light map density. And one other little thing, just because when we were playing around, you know, you hit play, as you can see, I don't have any sort of cast shadow on this guy. I don't want that. I want to actually still have a shadow casting on him. So what I'm going to do is I'm going to go back in here, and looking at my scene, we have these rect lights, which these ones are used to generate the color for the type of scene that I was trying to reference. But in reality, it should just be colored glass being that reason. But due to limitations with the baked lighting workflow with this one, it was just, for the time being, it was really hard to do. But I just use these guys to inject the color into the scene. But the other light that I had, which is this directional light, this one is also set to being a static light. They're all static lights, but there's no actual dynamic light. So if I hit stationary on here, I should be able to see now a light cast like this. So when I hit play, I should be able to actually see a shadow being rendered now. So I should be able to actually see some dynamic stuff. Though the colored lights, those ones actually won't work. So now let's go to build, and I'll keep my stuff at production quality, but let's see how long it works. So when you hit build status, it will start up the swarm agent, and the swarm agent, go down here, is this little kind of X shape. This will pop up the window to actually see how it's actually starting to try and load and render. So you can see here, distributing progress, looks like it's at 86% already, so it's actually pretty quick. But that's because a lot of my Lightmass settings were turned down. And you'll see the quality has kind of changed very, very drastically. Because now you can see that I have all these little speckles and stuff, and I have these like harsh lines because things are not blending as they should. Because again, the light mass is not accurate to what it's supposed to be. The other thing is also this. So this size, say if I bring him down to 2048, just tells me how many, this is the actual full size of each light map. So right now it's at 2048. So let's rebuild again. The other one before was 4096, which, you know, that can be a little high. So by default, it's usually 1024. But yeah, this value, the packed light shadow maps texture size, just packs all those baked textures that you get from the bake process and tries to compact them down to a texture size of something like this. And depending on how large your meshes are with their individual light map UV size, will tell you how many are going to fit within each one of the texture sizes. And as you can see, you know, didn't make too much of a change. Like I still have 46 light maps, but you'll see sometimes that it will make a quality difference. But let's go over in the light mass setting in here, what each one of these guys does. What this guy does is, and again, no matter what you do, depending, and this will actually tell you kind of what each setting does and if it's what direction it's going to do to change. But essentially, when you lower this guy down, the lower the number, the more amount of time it's going to take to calculate the size of scale of lighting. As in, like, if you have objects that are like a couple centimeters big, like really, really small, like maybe 10 centimeters or something like that. And sometimes if you don't have like, and you want like nice accurate shadows to go with it, like nice clean shadows, if you have this guy set at 1 right now, it means to say like, hey, guess what? This guy's like going to be, you know, doing a bake light at like 1 meter of scale versus like centimeters. So the lower this number goes, like 0.5 or 0.25 or even 0.14, kind of tells you how more accurate the lower the scale goes. So if you have small objects that you want to make sure they have accurate bake lighting, you'll use this. But this will drastically change the size of your scene. These two actually calculate how many extra bounces are going to be within the scene. So if you have, say, for this one, you actually, if you want more indirect lighting bounces, you can bump them up to 6. If you want this guy, you know, if you have skylighting, like if you actually have a skylight asset and you want more of that light injecting into your scene more, bump that guy up. I don't really have a skylight, so don't worry. But these two are where the other big pushes are going to be. The lower this smoothness goes, the more harder the shadows can be. So like if you do this guy to be like 0.35, then you'll have not too soft of like blends, but you actually have more harder, coarse lines for some of your bakes, which is good. But this guy is where you can start to smooth out the quality of the solver between the global illumination, like these hard lines and stuff. It actually will help blend it. So this guy, instead of going lower, if you go higher, like 10, this will help smooth and add more quality to your lighting and stuff. You can also use and generate ambient occlusion to your scene as well to help add more groundedness and actually calculate that stuff based off the geometry itself and not from the material itself. And, you know, there's other things too, like if you actually have, like say this guy, if this guy actually had an emissive material, like I think I should have a emissive material like this. If I want this actually being calculated into the scene, you can actually also do that as well too. You actually have to go to the cube mesh, like this guy, and you have to go all the way down to use emissive for static lighting. And that will actually allow you to inject the emissive in there. And you can actually boost the amount here. So the more emissive value will be contributed based off of these values. So if we hit this, let's hit our build lighting only. And let's see how long it's going to take, because it's going to probably take a lot longer now. So as you can see now that we've actually calculated everything, it took about 5 minutes to do, but let's take a look at our scene. And as you can see with the injection being brought in here, it is white hot, but you see how it's overloading so much more red in the scene. So it's cool to see that we can actually have emissives actually affect the world a lot more, but it's a little much still. And you can see that things have smoothed out a little bit more. The lines aren't as harsh, but you still see a little bit more of the prickliness here and there. So let's try and fix some of that. First off, let's undo the material that we were using before. So it was the asset platform one. So swap him out. And I'm going to change this setting just a bit more. I'm going to set him all the way down to 0.01. So now it's like every centimeter actually gets calculated with lighting. And one other thing, what I can do is I'll help smooth this guy just a little bit by bumping him up to about 0.5. Now, everything else should be good to do. Let's see. Yes, let's bake this guy out. Let's see how long it's going to take now. Okay, so this took just a little bit longer. It took about 8 minutes to do, but you can see it's a lot smoother though. If this guy was raised up just a little bit more and we had those kind of higher Lightmap UV sizes, we probably would have a little bit more smoother bit of surface. But again, this comes down to the fact that this texture is just a flat value. There's no real material to the surfaces, just like we had talked about in previous videos as well too. So one thing that you can try to make sure of is one, having a little bit more texture on there. If the budget, like say we go and take a look at our viewport stat, yeah, we're running at a pretty good 60 FPS, give or take. But there's other things also running in the background too. But for a scene like this, you can easily try and shrink the values down a little bit more. Like right now, everything's set to medium, screen percentage is set to this. If I lower him down just a bit further, yeah, see, we're now down to just a little bit under 18 to 20 milliseconds. But if I took everything else down off of the PC and try to run it, I think we would probably get a little bit higher, closer to like a 90 or 100. but having recording and all this stuff on the background can add a little bit more to what I'm trying to go for with this. But besides that, the only thing I wanted to quickly go over was the GPU Lightmass, so you can see kind of how it works. Now, with this in mind, let's go to here and pop up the GPU Lightmass. And you can see it either in real time. Real time will be slower, but if you turn off real time, it will go by a lot faster. You can calculate how many samples you want across the scene, how many stationary light samples you can do with this, and a couple of little things too. But let's hit build. And again, this will be in real time, so you actually will be able to see it happen while it's going on. So as you can see, it's starting to do the process. It has this thing where it just kind of adds these weird little progress bars across the scene, but you can see that it's kind of calculating as it's going. You know, it's almost like a path tracer where it starts off with like a rough image and then it slowly kind of goes further and further and further to see. And you can see here slow mode because it's in real time. If I had unchecked this, then it would go into more of a full speed, but even this is running pretty fast. And you can see, look, the image is slowly getting more and more clearer. The pixelation is getting better, and our little progress bars are starting to fill up on this, which is really nice. So yeah, this is definitely another thing you can also kind of have in your scene as well to do your calculations. Now, the other thing also I have not talked about is this is not the only thing that you can do to help with calculating your scene. So of course the light map baking is one of them, but sometimes if you have a very, very large scene, like big open scene, there's so much to do, but you have like a very small area you actually want to calculate. Like say you have a lot of trees or a big open background, but then you have just a very small area that you want to calculate towards, you can actually give a kind of priority to that baked area by using a special volume called a Lightmass importance volume. I'm not going to add it in, but I'll just show you where it is. So you'll see here, Lightmass importance volume. You can drag this in, and whatever fits inside of that volume will get more quality and more preference in the calculation versus what's outside of it. That way you don't spend a lot of extra time on things you don't necessarily need for your materials and for the scenes being calculated and stuff. But it is really interesting to, see all this stuff slowly start to progress. Though it is funny seeing this kind of weird, kind of broken looking progress bar as it's slowly going. Even this one too. But we're getting there. It's calculating fairly well, which is really nice. Yeah, 60%. And of course, you can also add in more changes to this as well. These numbers can also go up because it's a different kind of light mass being calculated. But these also still take into account the other options of like how large your Lightmass UVs are, how much more needs to be loaded in, little things like that. So definitely things you still want to kind of manage and take care of as you work on your scene. But looks like we're getting into the final stretch of things. Okay. And, like I had mentioned before, this scene is a lot cheaper than it normally would just because these guys that are being calculated are only being calculated as static objects. If these guys were brought on as stationary, that's where we would have a problem. The only one that's stationary right now is this guy. And if I wanted to make him more expensive, I can jump him over to being a movable object. So that's another thing to think about. 88, 89. Look how smooth it's slowly starting to process out. The image is almost done. Okay, 98. And then we'll have 99 and 100. And let's see what this looks like. There we go. Let's encode everything and calculate. So yeah, I mean, roughly not, well, I mean, it's not similar, but it roughly gives you an idea of the color at the very least, which is good. But it's the seams that are kind of the problem here. Like the way it's handling these modular pieces is definitely not desirable. Modular pieces are always really hard to get right when it comes to your assets. And one thing that I'll make a little kind of note of is these guys, the ones that I was using before, the reason why they look a little different compared to the one that was generated like this is these guys actually, and it's a weird kind of little hint, is these guys all fit within a certain grid size. Like I have every single one of these guys snapped to a certain type of grid, and that allows, for whatever reason, the light maps to not have as noticeable of seams typically. But again, this is just like a small little thing of, if you work on your own Lightmap UV, especially for modular pieces, try and snap the UVs to the closest grid point, and that will definitely help make it a little bit easier to manage. So I just wanted to quickly just go into mine and kind of show you guys about what it takes to make or modify Lightmap UVs. So here we have this asset right here. Just this is one of the blocks that I was using for that kind of simple hallway scene. And inside of Maya, and again, in other programs, it's very similar to Blender, 3ds Max. They all have the capabilities to control this type of effect. But you just have to make sure you go into your UV editor. And, as you can see here are my UVs. They are inside of the 0 to 1 space. But if I wanted to, I could take these guys and make some adjustments like, hey, what if I want like a UV set that allows me to use for textile density? And the problem with, say, this guy, he's a pretty large size. Like right now, if I look at the textile density of this object, what I would want is 512 per meter or 5.12 pixels per centimeter. And the current one is about half of a pixel per centimeter, which is definitely not what we would want. So if I want to use textile density, I can, of course, use this first UV set, or I can even make a new UV set. So right now I also have this. These are my Lightmap UVs. Let me quickly go over here and copy them over to a new UV set. So this is where you go in and actually play around with UV sets. Again, just kind of a refresher. If you guys have not seen, I would definitely recommend also going into the UV video that I went over what UV sets are. But think of them almost like changing the channel of your UVs. There is essentially the same amount of UVs, or you can even unwrap your UVs in a different way for a different reason. So my first UV set, this is for just general texturing if I want to bring this into Substance Painter. That's why it all fits within the 0 to 1 UV tile right here. For my second UVs, I can actually have these guys. First, let me just do modify, unfold. And let me just hit orient so that I can straighten them out like this. And now let's set these guys to the proper textile density, because I can use this for tiling textures. So I hit set. Now they're all the proper size. But again, these guys are outside of the 0 to 1 UV tile. And that's okay, because textile density in this case is good for tiling textures. So if I'm using fully tileable textures, I just want to make sure that their tiling is all accurate and is essentially the same throughout everything, as long as I make sure that I'm authoring my textures at a 1 meter type of size within the tileable section. Now, then I have my third UV set. Now, one thing to note is you can have multiple UV sets. The only cost is that there's small increments of data within your vertices. So sometimes the assets themselves take a little bit more to load, and they might be a little bit larger in size when you're trying to deal with them for the CPU and GPU and stuff. So just one thing to note, that every time that there is a new UV set, there is going to be an increment of cost, just so you guys are aware. So there is 3 in this case. The reason why I have a third one is, of course, my Lightmap UVs. But you may be wondering, well, what's the difference between this guy and this guy? Well, you could use this as your Lightmap UVs if you want to. You can even have Unreal Engine generate your Lightmap UVs for you. Like you could have either just one UV sets, or you could have two UV sets so that you can still do your texel density like this. Or in this case, you can actually set your own, because sometimes some people like to have their UVs done in a way so that there's not as many noticeable seams. Like maybe you don't want seams like right here on the split right here. Like maybe you don't want there to be a split from this guy to this guy, which in this case, there isn't one, but there could be one because of this. So try and hide your seams as best as you can, just a little bit better, just because you don't want the shadows to kind of interlay where they can be sometimes. The other thing is with your own custom Lightmap UVs is, in this case, this is something to do with Unreal Engine. So inside of Unreal Engine, when you're working on your modular pieces, sometimes you might run into an issue where modular kits tend to have noticeable baked seams, and it's not because of necessarily kind of anything on their own. It's not because like you're using a modular piece or you're using kind of a duplicate or an instance of it. It just has to do with sometimes how the light map calculates texture seams and doesn't try to blend them very well. And one kind of solution that I found back in Unreal 4 days was, if you were to put your UVs and snap them to the closest grid. In this case, I've shrunken my grid size to be something a little bit smaller. So if you go to view, go to the grid, and you can actually add more units and more grid lines, depending on however you want. But having them all kind of snap on here, because again, this is not for textures. Again, this is for light maps. Shadows themselves can actually be a little bit more fudged here and there because they're not as hard or as soft. Essentially, you're not going to see you're not going to see shadows actually stretch, because they're going to be almost like they're projected onto the stuff no matter what. So I went in here and actually made sure that every single one of my edges and vertices are snapped. So if I go into the UV aspect, you can hold X and you can actually snap to a UV grid if you want. You can even do half grids, but having them snap to the nearest grid, for whatever reason in the calculation phase for the light mass, actually helps with making sure that your scene doesn't have these like really weird light map seams between like shadows and stuff. It's just something that definitely helps a little bit better if you do that. So for modular cases like this, I would try to make sure to do something like this. And then when you import this into Unreal Engine, you just make sure you don't use generate light map UVs, and then you just choose your source light map to be the proper UV set. And remember, UV sets start at the number 0. So in this case, you have 0, 1, 2. So even though this is the third UV set, this is the second index or second UV set. I know it's a little weird, but that's just how we typically calculate things, is we start off at 0 first before we start going 1, 2, 3, and 4. But just wanted to kind of make a little small thing on this when it comes to UV sets and how to kind of create your own light map UVs. But yeah, overall, it's good to try out multiple UV sets. They're really useful where they need to be. And again, even in examples like I'm shown, I just wanted to quickly pop this up. So this is Matthew Johns, who's a principal artist over at Naughty Dog. You can see here for part of the Last of Us Part 1, the remake that we had done about almost 3 years ago now. Actually, no, 4 years now. Basically, when we're working on materials, sometimes for assets, we typically try to use multiple UV sets for different things. So in this case, we have this UV editor that you can see that there's one UV set, which is map 1. That's for your tilables. For things like decals, you can actually move around the decals with the second UV sets. These are just floating bits of geometry that are on top of the mesh themselves. Or in some cases, what we could do is you can actually move and adjust the geometry itself. So you can actually say, hey, right here, I'm going to select a certain piece of geometry and just only unwrap this and nothing else. And I can actually place these little tileable assets like this whale or this like dolphin or something like that as a mural, and you can actually give it a certain color. And how they also work is inside of this shader editor is that you can move these guys around in a certain way and set a color. So like here it could be orange, here it could be green, here it could be blue, here it could be red. And these are, again, different UV tiles. You can see it's how it's tiling multiple times. So he's moving these guys around and they just kind of change color wherever you have them placed, essentially. That's why you see them moving the colors and stuff as they are. But it's a really cool and useful type of workflow to use multiple UV sets and then just kind of have almost this weirdly procedural way of creating like things like murals in this case. Or you can even have other types of decals like signage or lines or kind of what have you. It really helps add kind of more, a little bit of, again, a better approach to creating kind of, again, procedural types of assets. It's a really useful workflow to have, but this is just one kind of example in a AAA type of workflow to use, but you can also use something similar in other cases. But yeah, just wanted to quickly go over an example of something like this. Oh yeah, the last one more thing, just to kind of showcase, just so you guys can see what it looks like. So if I bring in some lights, I'll bring in a few point lights. So I brought one of these guys in. This is what happens when you change the icons. So movable gives it this, stationary looks like this, and static just looks the same. But I have one here, I have two, I have three, and now when I have four, that is where you get that little X. And you're probably wondering, okay, well, I have four of these guys. Why is this one the problem? Remember, I also have a directional light in my scene that also is a stationary light. So even directional lights, if they are stationary, also count. And because they're infinite in size, they fit the entire scene. So this guy, as long as I move him away from like the furthest point light away, might have to move them like pretty far away. Because their area of influence is pretty far. So I probably have to move them like all the way over here. Yeah, so now he's stationary, but you can see that he doesn't have the X anymore because he's not overlapping anymore with all of this stuff. So I just wanted to quickly make a kind of small comparison between baked lighting versus Lumen in terms of optimization. So here we have a the city subway train modular scene created by Clinton Crumpler from Decagon. And in this scene, everything's been pre-baked. If I move any one of these types of assets, you'll see that it is a baked asset. And you'll see that right now we're running kind of closer to about 75 to, in some cases, 80, but with 13 milliseconds running. And it seems fairly reasonable. I could probably walk around this. It hits exactly the markers that I need to. You know, there might be other things that I might need to go into to kind of make small changes, possibly the types of textures. There's probably a ton of things kind of running in the background that might need to be changed. But overall, it's running, you know, pretty efficiently. I think it's not too bad, but also my PC is not the most kind of optimized when it comes to running a game typically, but it's good for making some nice stuff inside of development. But we'll quickly kind of pause here and I'll just hop into the Lumen scene and I'll show you guys the difference. Okay, so now we are inside of another kind of version of Unreal Engine that I have. Both versions actually were running in Unreal Engine 5.8. I just recently updated to kind of test some things out with. This guy is currently running at about the high quality version. Let's bump him up to about 75 screen percentage, just kind of see where we're at. And let's see, looks like we have a little tiny bit of a freeze, but not to worry about that. That just might be the kinks with Unreal Engine 5.8. So let's just wait and see what's going on. Okay, so freeze is gone, and it looks like we are running at about 38 to about 40 FPS, about double the milliseconds on this, which of course is not that good. This Lumen scene, of course, is actually using hardware-based Lumen. So if we go in real quickly, we can make some kind of changes to fix this. So let's do surface caching. And let's adjust, let's see, what else should we want to do on here? So we're doing surface caching. Mega lights is turned on. Our lumen refractions, turn on screen traces. And, you know, it's still about the same, but with 5.8, there's been small adjustments where you can now go into a lower version of the medium quality and you'll still retain Lumen, which is a really kind of big advancement at the very least, just because you can still get the Lumen-based workflows, but on much more not as performant platforms like Switch and Switch 2, and even in cases mobile platforms. So you can actually use much lower versions and still retain a basic version of it, and it looks fairly good so far. We've definitely gone from 35 FPS to now 60 FPS, which, you know, we are getting kind of closer to that baked amount. If we want to go a couple steps further, we can lower down the screen percentage to about 50%. For those of you who are not aware what screen percentage is, this is essentially you're lowering the resolution of the current viewport of the project. So my monitors are about 4K monitors. And at 4K resolution, you know, it's higher than a 1920 by 1080 full HD resolution. And if you want to see what the current resolution of your viewport is, because also it's based on the scale and also the aspect ratio of the camera that you have applied. So if we go into here into our viewport settings, you can see that the current resolution right now is 1538 by 860, because that's the current size of the screen. But the actual resolution that it was before was 3077 by 1738. So we're actually lower than full HD, and we're now getting about that 90 FPS type of value to it. So that's really good, actually. So we can hit closer to those aspects, but we have to pretty much lower the resolutions where we want them to be. If we want to get closer to a 1920 by 1080 resolution, let's get this to about, let's do 62. 63. There we go. So this is close to 1920 by 1080 resolution, and we're about 70-ish FPS. So we're at a pretty performant rate with Lumen on here with this fully diverse modular train with a lot of post-process effects. There's a lot of lights rendering in the scene. But in our case, most of these scenes are calculated just a little bit differently. If I want to go a couple steps further, I'll take this kind of somewhat unoptimized scene, because this is actually based off the actual original, which you get out of the scene. So we have a bunch of these lights right here that are actually using spotlights with, I think, a point lights in there as well. We can reduce those down to emissive lights. We can remove most of the spotlights that you see here in the scene, and we can slowly start to remove a lot of that information. So we can actually make this just a little bit more performant where we need them to be. It just all depends on kind of how we want to approach this. I would also even say, is in the bake scene, I would probably even try to remove more of these types of lights as well. I could remove a fair amount of these spotlights and just create one singular point light that can work for this particular asset. I could start to remove some of these kind of smaller lights and actually use emissive lights, because you can actually have those also affect bake lighting as well. We don't have to always use spotlights and point lights and everything else kind of in between. So I could slowly start to lower down the amount of lights within the scene and make sure that they're roughly within a proper performance. After that, it just comes down to what type of post-process effects, what type of kind of geometry optimizations that we can do. A lot of these assets that were created are, you know, fairly modular, I believe, but I don't believe there's that many. There is some teleblasts, but there's still a lot of these kind of uniquely made assets like the chairs and stuff. We could slowly start to go in and try to optimize the texture amount that's being called in. Some of these assets are, let's see, what is current resolution of this asset? 2048. We could try to lower these textures down to about a 512 to a 1024. You know, there's so many other different types of optimizations that we can do. Even just looking at the fact that there are different colors of these chairs, we could probably see if there is multiple versions of them, and we can just see if we can change it with a tintable version instead of a color version. There's many different things we can try with a lot of this optimization. But overall, this type of understanding of lighting is kind of one of the reasons why I wanted to go over the different types of lights, because one, lighting itself is a bit of a kind of hurdle to try to go through. A lot of artists have a hard time trying to understand lighting, and it's because they see lighting kind of as this kind of ambiguous thing. Lighting is very much similar to most assets you'll see in the scene. In the first video, when I went over kind of what the difference is between most of the lights are besides performance, is the shape that they are generating. If you try to break down your scene from what type of shape the lights themselves are and what type of tone and mood you want to try and set, you can easily create something with that information. The other aspect is gameplay. You know, if this is a train, you know, maybe there's something that's leading you from one train car to the next, or getting off to the next train station. There's, again, many different options for things like this. Now, the second video, and of course this video, goes over two different types of workflows that you can use. Baked lighting, with a little bit of time and patience, can get you some fairly accurate lighting. You can actually have dynamic and baked lighting together as one, but the problem is that even that quote-unquote dynamic is not as dynamic as a scene like this, where whatever I move within the scene will change the lighting. If I want to move one of these guys, or if I want to move one of these light fixtures, or just any one of these types of lights that are in the scene, I can slowly try to figure out what I could do to optimize this stuff a bit further. But the problem is with Lumen is that it's not just the fact that it's real time. It's the fact that even with this static scene, you can still see there's little flickers here and there because of how Lumen typically works overall. So for the time being, it just kind of comes down to what are you willing to use. If you're willing to have more of a real-time like type of scene, there may be some ways you can go into the rendering aspect of it to try and help kind of cull a little bit of these issues that you see, these visual ones, by trying to use other gameplay elements to help fix. Trust me, games do that all the time. If you ever have weird bake issues, artists tend to just cover up seams and bake issues with other things like decals and stuff. So that's kind of the gameplay aspect of it, or the game development aspect of it. But if you're willing to use baked lighting instead of Lumen, which, it's understandable, just know that, there are some pros and cons to go with it. You may have more of a real-time optimization, but you may garner a larger disk install base because of using the light maps themselves. Let me see if I can quickly kind of pop up with the old scene and kind of show you what the example of how many light maps were in that scene. Okay, so now we're back into the scene. I just wanted to kind of quickly go into the world settings, go down to my light maps and see, yeah, this scene uses about 1,200 light maps themselves. And again, this is the overall amount of them. This doesn't mean that there's over 1,200 textures. It just means that there are 1,200 different asset light maps that will be compressed into atlases later on. And the pack sizes for this case will be 4096. We can, of course, lower that down lower and lower, just try and help make the less amount of textures, that are that large to be. But again, there's gives and takes with both workflows. This is kind of how it is with games. You're never going to be able to just have every amazing feature turned on. You have to kind of look at what you're trying to look for within your game and what type of look, feel, vibe, and see what you can do with what the tools you currently have. That's kind of how games always are. There's always a give and take somewhere along the line. So with that, this concludes our last lesson on kind of general lighting overall within Unreal Engine. In my next few videos, I probably will start to go back into materials themselves, probably start more off with like Substance Designer, just because it will be a little bit easier of a subject to kind of start to kind of get towards, and maybe make a small series out of that, just because materials are always good, and substance is always a good thing to kind of pick up more on. So thank you guys all so much, and I'll see you guys in the next video. Take care.